So, what we're trying to do is expand our understanding of sets and how to talk about them in particular, okay? Because just like in normal language, right? For instance, we have words like, say, you are. When we talk in normal language, we say, this language is fine, it's good, but we sort of take words like this and we contract them, right? We say things like this. We invent a new word, right? Because expanding our language by taking other things, right? It helps us to communicate faster and more efficiently, okay? So that's kind of what we're going to do today. We'll start off nice and gently, okay? If you see something like this, right? A set, and you've got n of A, that's how I read that, okay? This is the number of objects in set A, or if you like, it's the set size, okay? So this is the size of set A, okay? Now so far through this topic, we've sort of always been starting from scratch and said, okay, there's a universal set, let me tell you what numbers I'm interested in. And then I'll say, this is set A, this is set B, and it's in some ways completely arbitrary, right? But there are some sets that come up over and over again. Just like the phrase you are comes up, we say it hundreds of times a day. So it makes sense to have like a shorthand way to say it, okay? So I'm going to tell you about some important sets. So, subheading, some important sets, okay? Now there's an order to this. I'll try and do it right in my head. All of these sets, because they're special and we want to recognize them, rather than just using letters to do them, it's a bit like this. See how this is a special U? And when you see it, you're like, universal set. Okay? So these extra dashes come up a lot. If you see an N, right, but it's got an extra line in it, like that, okay? So N stands for the natural numbers. The natural numbers. Okay? Now, I would love to give you a completely unambiguous definition of the natural numbers. The problem is, there isn't one, okay? So I'll give you the two definitions, and you might be able to think of why there are equally two, right? The natural numbers, who would like to give a suggestion? What do you think the natural numbers are?
All the numbers that exist.
All the numbers that exist in nature? What kinds of, can you give me some examples? 1, 2, 3, 4. Okay, now, see, the other name for natural numbers is the counting numbers, but I'm avoiding that very deliberately. You'll see why in a second. One of the classic ways to define the natural numbers is to make it this set. 1, 2, 3, 4, and so on. Forever. Okay? These are the counting numbers, unambiguously, right? But some people say, hey, you know what? You're kind of missing one of the most important numbers in there. Maybe the most important number. Which is, well, what happens when you're counting, but there aren't any there? And the answer is that's 0, right? So that's kind of a notable absence from this list, okay? Now here's the problem. I can't avoid the language of natural numbers, it's important. Half the world means this when they say natural numbers. And the other half of the world uses that. There's no consensus whatsoever. Some people, to make sure it's really, really unambiguous, they'll call this one N, and then they'll put a little subscript 0 next to it, right? N0 or N0, okay? And that means you definitely have to include 0. But sometimes it goes either way, right? But it, nonetheless, very important set of numbers. Yes?
Is it kind of like 0 kind of ruins things?
Yeah, now here's the thing. 0 ruins things sometimes, but not all the time, right? So depending on where you are, that's why some people use one or the other. Okay. Now, let's go from there to a far more, actually the rest of the sets are completely unambiguous. The next one is a Z, okay? Now I'll tell you what Z stands for in a second. It's very familiar. It's a set of integers, right? Now how are the integers different from the natural numbers? What do the integers include that the natural numbers don't have?
Positive.
And the answer is, well, obviously these are whole numbers, but I don't have any negatives here, do I? Right? 0 is not negative. He's special, okay? Integers adds in the negatives, okay? Now, the reason why it's Z is that's a reference to, a German word, Zahl, right? Which has to do with counting and wholeness, okay? And that's kind of it's a a tip of the hat to the fact that Germans did a lot of incredible mathematics and a lot of development in this field, in understanding this field. You're like, what's to understand? Well, a lot. We'll get to that a bit later on. Okay. Now, there are two subsets, we know what that means, of the integers, very simple ones. Yeah, the positives, z plus, right, and that's a superscript, it's above, and z minus, okay? That's in a different kind of, you see, if you're talking about limits, you can't approach a set, because it's like, which part of it are you approaching, right? So this means positive, and this means negative.
These are also called
Sorry, Nikita, I'll just wait for the rest of the class. It's just a bit sad when you have to do this in a class where people choose to be here.
These are all still
These are all still
whole numbers.
whole numbers. Okay. Which then raises the question, well, what about the numbers that aren't whole? Okay. Now, I wonder what you would call as the letter that you would put for the next set. Right, we're kind of trying to expand our horizon of all the different families of numbers. Okay. Brendan, were you going to suggest something, or was it a question, or?
Is 0 part of the integer set?
It is.
Well,
Yes.
It's not neither, is it?
No, that's right. That's right. So it's a bit funny, isn't it?
They're not complements.
If that's exactly right. If Z was your universal set, then these two are not complements because they're both missing 0, right? So 0 would be, yeah, it's outside. Yeah. 0 always, see, you would be in this camp, obviously. 0 is always ruining things.